Bismillahirrahmanirrahim. Today we are starting exercise 11.6 from for additional mathematics subject. The first problem is the first term of a progression is 8 and the second term is 12. Find the sum of the first 6 terms given that the progression is arithmetic. In case of B, if progression is assumed as geometric. So we have to find we have given first term and second term and find the sum of the first 6 terms given in the progression. So we will solve it. We have given a1 is equal to 8 and a2 is equal to 12 for geometric progression, and for arithmetic progression the same is 8 and comma 12. This is a plus d. So for AP we can solve it for 6 term. We have to obtain the sum of the 6 series up to 6 term. Sum of up to 6 term is given as S6 is equal to, in place of n we can write 6 by 2, 2a, a is given as 8 and n is given as 6, and the difference between this is d, which is 4. So we have obtained S6 is equal to 108. For geometric progression we have 8, 12 and this. So we have 8, 12 and the next term is so we can find out the value of r from this ratio AR and R. So we have AR divided by A, the 12 divided by 8 is equal to 3 by 2. For 3 by 2 this is R, and in place of this we can place R and find out this S6 as 166.25 or 166 1 by 4. So this is the sum of geometric progression up to 6 term, and this is a sum of 6 term for arithmetic progression. So this was the requirement, so we have obtained it. Now move to the third exercise, problem number 3rd. The first, second and third term of a geometric progressions are the first, fifth and 11th terms respectively for an arithmetic progression. So the first term is corresponding to the first term, and second term corresponds to the fifth term, and the third term corresponds to the 11th term. The first, second and third for geometric progression corresponds to the first, fifth and 11th of arithmetic progression. So we will write it in our working. This information, this is given that the first term in each progression is 48. Also a is equal to 48 for both progression, and the common ratio of the geometric progression is r, and r is not equals to 1, means r is less than 1, because we can know that the r should be less between -1 and 1. So find out the value of r. For this value we will find the value of r and the 6th term of each progression for arithmetic and geometric progression. So we have to calculate the a6 for both progression, the 6th term. So means AR5 for AR5, A R power 5 would be the geometric progression, and for arithmetic progression that would be A plus 5D. So we will obtain this information. So we have solved it in part 3, question number 3. So this is the given information. The geometric progression of first term, second term and third term corresponds to first term, fifth term and 11th term. This is the given information in the problem. And secondly, this a1 is equals to 48 is a1 is basically a is equals to 48 in both progression for geometric and arithmetic progression, and r is not equals to 1. This is the given information. We have write down again in a systematic way so that we can solve it appropriately. So we have given this information, we have draw it here, or the value of, we have to find the value of r. as per given information we have this corresponds to this. So for this geometric progression we have first term is 48, second term is 48r, and third term is 48r square. Second is similarly for arithmetic progression, this corresponds to the first term, so it is 48. For the second term, this is for fifth term of the arithmetic progression, so this is 48 plus 5d. This is the 11th term of arithmetic progression, corresponds to the third term of the geometric progression, so it is 48 plus 10d. So from these two equations we have this information. This is 48r is equals to 48 plus 4d. This is given information. 48r square is equals to 48 plus 10d. So by solving this, we have r and d in a two equation. We can solve it very easily. So from first equation we will obtain this. Here we can simplify it further, but we have placed it here as it is. So from equation 2 and from equation 1 we have obtained d value in terms of d, so we can equate both. So we have equated here, and from here we have obtained the value of r. By solving it like this and by minimizing or by simplification, we eventually obtained as this, and r eventually comes to 3/2. So this r could be used to solve geometric progression and arithmetic progression. So for B part we have to find the value of sixth term for arithmetic progression and sixth term for the geometric progression. For first we have this r value, so we can easily obtain a6 as 48 3/2, and this is n minus r. Here this is 6, so 6 minus 1 is 5 here, so this is the sixth term, so we have obtained as 64.5 in geometric progression. And for arithmetic progression we have this 48. Here we can take 4 common, so by dividing it, or this 48 common, so it becomes r minus 1, and we divide the 48 by 4 to obtain 12 comma r minus 1. This d is equal to 12 comma r minus 1 bracket. So we have obtained this as this here. This is the same equation, the first one. So it was 48 minus 48 divided by 4, 48r minus 48r divided by 4. So we can simplify it and write down like this. So in place of this we have placed this value of r here and find the value of d. This d value is used here to obtain the sixth term as it is. So we have obtained sixth term of the arithmetic progression and sixth term of the geometric progression. That was the requirement of the part B. So we have solved it here. Now move to the another problem. Let's move to second problem. Third problem has been solved. Now let's see the sixth. The first term of an arithmetic progression is 12, and the sum of the first 16 term is 282. Arithmetic progression. This is arithmetic progression AP. The first term is given as 12, and the sum of first 16 term is 282. So we have to find the common difference of this progression. So we have to find the common progression of this problem, that is problem number 6. So for this information we can use it in our problem. And let's see the second part. Find the common difference of progression. The first, fifth and nth term of this arithmetic progression are the first, second and third term respectively of the geometric progression. So the first, fifth and nth, first, fifth and nth, this corresponds to the first, second and third, first, fifth and this nth term, right? So we will solve this corresponding similar. It was the same problem as we discussed recently. And second, in the second part, we have to find the common ratio of the geometric progression and the value of n. So now let's move to the working area for this problem. This is problem number 6. We have this information: A is equal to 12, S16 is equal to 282 in arithmetic progression. This is the given information, so we will use it in as this S16 as this. So this is Sn n by 2 2a plus n minus 1 d. So in place of n we will write this 16, so 16 16 and here 16. So we can find the value of d from this part. The d is unknown, so for simplifying we have obtained this value of d as 0.73 or d by 3 by 4. So this d is obtained, and now we will place the corresponding values is given as a corresponds to a, and this first term corresponds to first term, the second term corresponds to the second one. This is the fifth arithmetic progression corresponds to the second term of the geometric progression, and nth term of the arithmetic progressions corresponds to the third term of the geometric progression. This information is given in the problem. So by using this information, we have this AR is equal to a plus 4d, and for this information we have AR square is equal to a plus n minus 1d. So for this problem we have obtained the value of d from the previous case, so we have placed the value of d here, and we have AR is equal to 15, and a is given as 12. So in place of this a we have write down 12. So this 15 divided by a, which is 12, so 15 divided by 12 is equal to 5 upon 4. So a is common ratio is obtained as 5 upon 4. So for this part we have solved it, and now we will substitute this value of r in this equation. Value of r, we will place the value of r in this equation. This is 15, this is r, so this is AR is 15, so we can place it here, and this is r, we have placed it. The value of r is equal to 5 by 4, so this is 12, this is n minus 1. So we have obtained the value of n is equal to 10 by simplification. So we have to simplify, and we have eventually obtained as n is equal to 10. That was our required value. Now let's move to another problem. Problem number next we solve problem number 8. The first two terms of a progression are 5x and x square. So this is first term and this is second. If it is arithmetic progression, this is a, and this is a plus d, and for geometric progression this is a, and this is a multiplied by r, constant term. So for the case where the progression is arithmetic with a common difference of 24, the common difference between this is 24, so the d is 24 is given. Find the two possible values of x. So we have to solve this problem to find the value of x. All possible values of x, we are here, two possible values will be obtained, and the corresponding value of the third term. So we have to obtain the third term for both cases, for arithmetic progression and for Okay, so in a part 2b, in a part 8b, we will solve for the case where the progression is geometric with a third term of this third term. Here we are considering the third term in a geometric progression. We are considering the third term as a minus 8 upon pi. Find the common ratio and sum to infinity. We have to obtain the sum to infinity for this particular case. So let's move to the question, the part number A, problem number 8, solution of problem number 8. This is the given information. This is first term, this is second, this is A, this is A plus D for arithmetic progression, this is A, and this is AR for geometric progression. So let's start with the arithmetic progression, where the D is given as 24, this is X, and this we have to find the third term. So A is given as 5x, and A plus D is given as x square. A plus 2D, we have to find the third term, that is A plus 2D. So we start with A is equal to 5x, and the difference is given as A plus D minus A is equal to x square. This is A plus D, this is A. So the difference between this is D, which is equals to 24. So we have write down is the here is 24. So x square minus 5x is equal to 24. So we have to write down like this. So for this we have two possible values of x minus 3 and x is equal to 8. For x is equal to 3, we have to find the third term as this. For x is equal to 8, the third term is given as A plus 2D. So in place of D, we have placed this value, and we have obtained the third term as 33 or 88. For x is equal to minus 3, it is this. For x is equal to 8, this third term is 88. Now in part B, the first term is given as 5x x square, and the third term is given in the part B as minus 8 upon 5, and we have to find the value of r as well. So this r is the ratio of x square divided by 5x. So with this write then. Similarly for this to this, we have the same ratio, minus 8 by 5 divided by x square. This is again, because this is AR square, this is AR. AR square divided by AR is equal to R. So this is again same. So we have this value. So we cross multiplied it to obtain this, and from here we have solved it to obtain this. Simplify this 5 cancel with this. So x4 is equal to minus 5x 8x, sorry, this becomes 8x. This when we shift it to here, the left hand side, it becomes plus 8x. So from this we take out x as a common, so equal to this. So x is equal to 0, or x cube plus 8 is equal to 0. This is not possible. So x cube plus 8 is equal to 0. So x cube is equal to minus 8, x is equal to minus 2. So we have obtained x is equal to minus 2. This in place of x, we can write down this minus 2. So obtain the value of r as minus 2 by 5. By 2 by 5, this is a common constant ratio for geometric progression. So we can write down the value of r here, and a is given as 5x. This is 5x. Value of x is already obtained as minus 2. So in place of this, we have write down this minus 2. So this is a 5x, which is earlier given as this 5x. So this is 5x. So we'll write down here 5x, which is a. In place of x, we have write down minus 2 as we obtained earlier. So on simplifying, we obtain s equal to minus 7, 1 upon 7. So this was part D. Now we will cover next exercise, that is the exam exercise 11.7 in